What up, fourth period? Sitting here on a Sunday watching some college hoops and making this video. It's going to be a quick one. It's going to be about 12 minutes. So lock in, learn as much as you can. Remember to send me a message at the end of 2 things you learned, 1 question you still have. And hey, somewhere in the middle of this video, I am going to reveal my Mount Rushmore of fast food restaurants. And I want to compare with you all's tomorrow in class. So once you get there and see mine, you can get ready to rip it to shreds and come up with your own. Okay? But we are talking about radicals. And we went over a bunch of these notes today in class, talking about, different terminology and how to simplify. And I want to do a little 3-minute introduction on something that I maybe forgot to do in class. Because there's a big connection between exponents and how they work, and so we're going to actually call this the Laws of Exponents here. You could even Google Laws of Exponents and it will come up with some, but I'm going to give you just like the 5 or 6 most important laws of exponents because I think it's really helpful and it connects to this unit and it will connect to the next unit. Okay, so these are just mathematical properties. This is the way that exponents work. And we could go into a lot of detail, but I just am using this as a refresher course because I think you've seen that at least once before in your life. But when you're multiplying 2 things, we'll say x squared times x to the third, you add the exponents. Okay? When you are multiplying 2 exponents with the same base, x squared and x cubed, you add the exponents to get x to the 5th. Okay, that's going to be our first law. Second one would be this. What if you had x to the 2nd power raised to the 3rd power? Well, that would be like x squared times x squared times x squared, which you can already see would be 246. So it would add up to be 6. But we can just do a shortcut, and if you have what's called the power rule, power to a power, 2 raised to the 3rd, you do multiply the exponents. And you'd get x to the 6th. Okay? Let's do another one. That's where if you divide, what if you had 3x to the 5th divided by x to the 2nd? Okay? If you ever have that rule, you subtract the exponents. And you would get x to the 3rd. Okay? Because you can cancel out. Like sometimes when we do problems, we might have like x to the 6th, like 5x to the 6th over 2x squared. Well, these 2x's down here could be canceled out with 2 of them up there, which would turn that to a 4. You're basically subtracting, but what you're doing is like if you had 4x's up top like this, like if we wrote that all expanded out, and then we had 2x's down here, what you're doing is you're basically canceling the bottom 2 for 2 of them off the top, right? So when you're subtracting exponents, or when you're dividing exponents, you're subtracting. 2 more. If you have, let's say, x squared y to the negative 3rd, negative exponents move to the denominator, or if they're already in the denominator, they move up to the numerator. And it would, we'll say negative exponents move to, we'll call them reciprocals, because that's what they are. A reciprocal is where you flip something, right? So negative exponents are reciprocals. So x to the 2nd, y to the negative 3rd, that x to the 2nd doesn't move, but look where that y to the negative 3rd goes. The negative 3 power moves that to the bottom, and it becomes a positive. Okay, so anytime you have, like, let's just say x to the negative 6, we want to rewrite this as just 1 over x to the positive 6. Those are the same thing, these 2 things right here. And in math, we don't really like negative exponents. Okay? So that's the 4th one that we're going to go over. And then the last one, which leads us right into our unit, is if you ever have x to the 1/2 fraction exponents, fraction exponents are square roots. We'll call them radicals. A 1/2 power is square root of x. Okay, we talked about this yesterday, right? So I'm not going to go over it too much, but the number on the bottom goes right here. and the number on the top goes in here. Okay, so if you had x to the 2/5, you could also rewrite that as the 5th root of x squared. Okay, those are just some exponent laws. You see those on the SAT and ACT all the time. It's just good algebra to remember those rules. And so I wanted to start with that little mini lesson. Okay, let me jump over to the notes here and do 5 or 6 examples, and then we got to go to Mount Rushmore of fast food at some point. We did all these in class, so I'm not going to do those. Let's just start here. We might have gotten here in class, but maybe you missed class, and this is a great review. When you are multiplying radicals, all right? When you are multiplying radicals, they have to... let me rephrase this. When you are multiplying radicals, what you're doing is you're allowed to multiply what's underneath the radicals. Okay? And they need to have the same base, or they need to have the same radical expression. Sorry, I'm getting tied up. I'm moving ahead to adding and different things. So let's just focus on the now. Okay, this is fancy. It says if the square root of something and the square root of something are real numbers, okay, which is just not imaginary numbers, then what you can do is you can combine them into one radical. That's what we're going to do here. So the square root of 3 multiplied by the square root of 12 can turn into the square root of whatever 3 times 12 is, which is 36. And then this can simplify to 6. Sorry, I didn't mean to put that. Square root of 36 is 6 times 6. It's one of our perfect squares that we went over yesterday. Okay. What about this? Is this a real number? The cube root. You can do cube roots of negatives. Okay, so that's going to work out. So the cube root of negative 16 times the cube root of 4 is going to be the cube root of 16 times 4. 4 times 6 is 40. 40 plus 24 is 64. Okay, so the cube root of negative 64, you can use your calculator to multiply that. So can I think of, is that a perfect cube? 4 times 4 times 4 is 64, so that's actually going to be negative 4 times negative 4 times negative 4 is 64. So we'll skip over this. I'll let you solve it, but it'd be the square root of whatever negative 64 is, and we can't do the square root of a negative. That would be an imaginary number, so that's going to be no real solutions. We won't deal with imaginaries right now, okay? So no real solutions. Let's talk about when there's variables here. I'm just going to pick a random one. Let's do yeah, A is perfect. Square root of 50x to the 5th. I strongly recommend that you do these one at a time. Like, first thing, what I mean by that is let's deal with this coefficient here first, and then we can deal with the variables. Okay? So the square root of 50, our goal, remember, we talked about this in class, but you have to look for perfect square factors. What does that mean? It means that the number 50 is not a perfect square. Our perfect squares, remember, are 1, 4, 9, 16, 25, 36, right? 49, 64, so on. So I can break this 50 down into 2 factors, and the perfect square that's in there is 25. So the square root of 50 is the same thing as the square root of 25 times the square root of 2. We just talked about that. The fact that root 25 is a perfect square, that's why I chose it. The square root of 25 will give me a 5 out here, because it simplifies. Okay? It simplifies. This square root of 2, on the other hand, will stay underneath, because it cannot simplify. So we dealt with the 50. Now we have to deal with the x to the 5th power. Okay? So off to the side, just to teach. X to the 5th, that's an odd number. And we talked about this today in class. But with variables, if it's an even number, the square root of x squared is just x. The square root of x to the 4th is x squared. The square root of x to the 6th is x to the 3rd. Even number variables are all perfect squares. Okay? Because of our exponent rules that we went over. So if you see an even number, you're golden. If this was a 6, the square root of x to the 6th, we would put an x to the 3rd out here and be done with it. But it's not a 6. It is a 5. So we break it down the same way. And what is the biggest perfect square within that would be x to the 4th. It's always the biggest even number. Let's make sure this is right. Is the square root of x to the 4th times the square root of x the square root of x to the 5th? Sure is. So hey, this is a perfect square. The square root of x to the 4th is x squared. And then there's this x that's left over on the inside. This is our answer. Notice, what I highlighted in yellow were perfect squares, and those came outside. They simplified out. Okay, that simplified to this, and that simplified to this. But the root 2 and the root x, they couldn't simplify, so they stayed underneath our answer. This right here is the same exact thing as our original problem. It's just simplified. Okay, we'll do more of that. But I just wanted you to see that example. You should try one with B. Try breaking this down. Try breaking this down. See what you get. You can check the answer key. Cubes are the same, but you're just dealing with perfect cubes. What's a perfect cube that can go into 54? Remember, our perfect cubes are 1, 8, 27, 64. So you need to see if any of those factors can go into 54. And then with our variables, is it divisible by 3? So n cubed is a perfect cube. N to the 6th is a perfect cube. Is it divisible by 3 is how you have to operate it. Okay, so we're multiplying here. It's just same thing. Whoa, what's going on? Let's talk about this. There's one new piece, and then we'll finish, because I told you 12 minutes, and we're already here. When you're multiplying here, you still would do this times this. But hey, we multiply what's on the outside as well. So this would turn into 3 times 2 is 6 on the outside. And then 7 times 21 is 147, I think. Shows how my mental math is broken on a Sunday, but let's just do 21 times 7. Yeah, 147, shout out. X to the 3rd makes x to the 6th, y squared. So there is our new problem that we have to then break down. Honestly, maybe you just break it down right now. I don't know if we can, though. 21 has no perfect squares. So yeah, you just multiply those together and see where you can go. Okay, we'll pick this up tomorrow in class. We're going to work on the dry erase boards. We'll talk about dividing, what it means to rationalize the denominator, and then how to add, which, believe it or not, is a little trickier. But all that's tomorrow. Hopefully this video helped give you some basis. So now for my Mount Rushmore of fast foods. Okay, remember Mount Rushmore is 4 kind of faces. Oh, that's terrible. My number 1 on my Mount Rushmore. Well, these are all equal. Okay, these are all equal. I gotta spread the love. Okay, first one. Gotta go here. It's non-negotiable. The milkshakes, the fries, the chicken sandwiches, the Chick-fil-A sauce. Come on now. Second one. Don't judge me for this, but I can't ever turn down some late night Taco Bell. The price, the amount of food you get, the sauces, Baja Blast. Come on now. And then, hey, I got chicken. I got Mexican food. Now I got to go with a burger. And in my opinion, Culver's is my spot. Cheese curds. You can get ice cream if you want, and they're double butter burger with cheese. And the last one was a toss-up because I got chicken, I got Mexican food, I got burgers, so I just went with my favorite. And maybe it was my year in New Orleans, but I'm a sucker for some Cajun food. Those fries, that new chicken sandwich, those red beans and rice, and the spicy mashed potatoes. So, I mean, I could die a happy man if I only ever ate at those 4 spots the rest of my life. So I'd love to hear yours. Tomorrow, hopefully you learned a little something. Send me that message to get credit. Have a great day.